right, everyone. You are welcome and thank you for joining today's session. So, as we are all aware, in today's session, we'll be kickstarting and officially venturing into database. So, specifically on SQL, that is SQL. We would be having a comprehensive approach to learning how to use this technology, right? So for today's episode, we'll just be learning the overview, so understanding what this concept is as a technology, right? Because I believe once we are familiar and we can appreciate this basis, so working with them would just become second to nature. So this is what I like preach and advise. So the first thing you would want to learn as a learner of software engineering is to first understand the logic and like the rationale of a technology you are trying to use. So once that sinks and sticks, right? So it's just like molding blocks on a foundation. So having said this, right? So again, I welcome you all to the session. So database. What is database, right? So database, it's not an alien word. So it is not something that is far-fetched. So it is something that is actually traditional to each and every one of us. So one time or the other, we have all related with database. So even domestically, it's something we have used, right? Knowingly or unknowingly. So it could just be like a traditional approach or unstructured approach or a non-systematic approach, like of what of gathering and retrieving data. So now in this scope that we will be like learning today, so it will be different from what we are familiar with. So however, um today this will be our session overview. So we'll be understanding what database is, and also knowing what database management system is. When we know what database management systems are, so we also need to understand the types so that we can know which suffice for a specific project or program we are working on. But in our own case, so our own interest is relational database. So we are going to understand in depth what relational database is. So why is it coined or termed relational? So is there something or somewhat a relationship while using this technology? We are going to understand that in the course of this session. So also upon understanding, Victor, you are welcome. Upon understanding the logic and the rationale of the relational database, right? So there are some things I myself, I term them as the foundation or the components of database management system. So they are just like, to put it simply, so they are just like features or expectations or characteristics of a database, right? So let me cite an example. So if we say something is a computer, so we have an expectation for computer, right? So as a developer, as a programmer, your expectation amongst your expectations should be or could be you should be able to use a computer to build software or to build application, right? So to others, they also have their own words, concerned and interested expectation from a computer. So now in the case of database, what are the expectations, right? So if we say you're a database, right, we are relying on you to store our data, and when we need this data, would you be able to provide it for us? Okay, fine. I have stored a data. I want to update it. do you have this capability? To an extent, this data is no more useful. I want to dispose it. Is this something you can do? So these are just basically what the ACID, it's just an acronym, ACID. ACID is actually more of like an integrity, or or in other words, it can also be referred to as a feature that can make us to trust a database. Yeah, like building a trust relationship with our data, right? So there are also like expectations to that regard. So once one or many of these are not met, so databases it's just it's of no use, right, to us. So now when we understand that, we would also be looking into table. So what table are? So the term table. So what does it like enunciate, right? So what does it translate into? So we'd also learn row, column, and also the infamous primary and foreign keys, right? So these two concepts many times seem intimidating. However, they are not. They are not. They are very primary. They are very regular operation of a database, very regular. So we are going to understand that and appreciate that in a moment when we get to that section, right? So then we'll wrap it up with just basic, introducing ourselves to basic SQL commands, right? So just being familiar with the commands. So um, as we are all familiar with the shell or the bash script commands, so to list our files, so we know what to run, to query it, and request the terminal to list our files to make a directory and the host of others. So we are going to also be checking and be reviewing some of these commands, nature or native to SQL. So now here I have what I coined to mean what a database is. However, before we proceed into our major concern of what a database is, so I would like to take us back and bring it very close to us, right? So that we can use this resonance, right, to relate to what a database is. So this would interlock to what a database is, and it would also open a flow for what a database management system is. Then everything would interconnect to make it a whole. Then it makes sense going forward. So let's think about how hospitals used to operate shelves. So I believe in one time or the other, we would have visited like an healthcare facility. So while we on our visit, right? So we would understand that even in this contemporary, there are still some hospitals that still run traditional shelving of files, right? So they just have a way of arranging patient files, so which will be retrieved upon requests, right? So this is native to a way or an approach of storing data. So data is just an information or a record, right? A base is where it is kept. So now joining both words together makes database. Now, in our own interest, like now we want to be technical now, right? So moving away from hospitals, schools, and businesses that get ledgers for every transaction. So we want to relate it as an engineer, right? So as an engineer, our own understanding would be different from others who are not in the field. So to an engineer, we can say a database is an organized collection of data, right? So that is stored and managed in a way that allow efficient retrieval, manipulation, and maintenance of information. Now, this would strengthening or optimize data retrieval, right? So because we would have a system that stores it, so we don't require manual indulgence or manual retrieval. So we shouldn't go and undergo that Herculean task of retrieving information that are stored, right? So because comparably to the native way of storing data, so we would need to manually check the shelf rack to retrieve a specific data, right? But in this case, once it is being kept logically and it is structured, so the system would allow us or gives us an approach or a method or a way to us to perform an action on that data. So those actions are what you would also be understanding in one of our next slides. So I believe database should now make sense now to a very large extent. So now having understanding what database is, so it is incomplete without um, affiliating it or making it sync with database management system. To some, it confuses and they consider them to be the same. And however, they are different, right? So they are different. They are just, I would put them simply to just be like a mean to an end, right? So they are relatively different in terms of concepts, right? So database management system is just like a software system designed to create, manage, and interact with databases. So again, it's like a system designed to create, manage, and interact with databases. So now let's say, for instance, we understand what database is, right? So we now want to have like an intermediary, a middleman that we can send the errand to go and query where we keep our files. Okay, fine. Oh, AU, I want you to check on this specific file, right? Giving it its query. So giving it the sequence, right? Or the query to understand. Okay, fine. Depending on the action we want to perform at that minute, right? Okay, fine. Are we trying to create? Are we trying to read? Are we trying to update? Or are we trying to delete? So this is what DBMS would do, right? So it just acts as an intermediary between database and applications or users. So it provides structured and organized way to store, retrieve, and what manipulate data. So now, if we now say we understand what DBMS is, right? So DBMS as it like it varies, right? So and this variant is obtainable depending on the objective of our projects or the complexity of our projects, right? So this concept is actually arguably arguable, right? To some, they consider them or they fathom them to be competitive, right? So you would be hearing such buzzwords such as no SQL is better than SQL, right? While to others, they also like they are steadfast on the use of what SQL. So I think it's safe to denounce that notion or that assertion, right? So each of them have their what specific and unique use cases. So once we understand the use cases of one differently from the other, so it begins to make sense. Now, what are these types? So the first one is what? Relational, right? And the other one is non-relational. So when we say relational, so relational database is one of the first thing you need to commit while trying to understand why it is called or termed relational is what? The first one is what? It's structured, right? So this structure, its states of being structured. It's also like a genesis of its name. So because it's actually a data entry in a what, in a table, which must conform to a defined schema and constraints. What are the schemas? What are constraints? So schema is just basically like, let me say, a template, right? So okay, fine. I want to um, define a database. So I want to define a table. So anytime you hear me use table, so table is relative to relational database, right? So table is relational to it. So one of the forefront meaning for it being relational is because data are stored in a what? In a table. And when something is stored in a table, so expectedly we would have an expectation of it to be what? To be arranged in a specific order. So if, for instance, we say that, okay, fine, we have one thing that is also native to a table is we should have a colon, and we should also have what? A row, right? So okay, fine. In this colon, what should be in the column? In this row, what should be in the row? So that is basically what schema is. So anytime you hear schema in what? In database, it just means like, okay, fine, why you are defining or declaring the table. So what was your definition? What did you define it to mean? How many colon did you define? So, and expectedly, what are the constraints attached to the what? To the rows or to the record you want to store in the what? In the table. So we would be venturing into this extensively in a moment. So let's just see this as an overview, right? So that is just what relational database is. So and it allows us to also what? Query and manipulate our data and our information. So as I have stressed earlier. So an example is MySQL, right? So we also have PostgreSQL. We also have what? Oracle. So we have amongst others and a host of others. But these are just the what? The forerunners, right? When it comes to relational databases, right? So now we would all agree that our own interests is basically on what's on relational database, and we should be using MySQL as what? As the technology. So again, our interests, our focus will be on relational database management system. So now, when I was explaining management system, I said it's like a software designed to what? To manage and interact with data, serving as like an intermediary. So now that software is this MySQL. So what we are learning is MySQL. Does that make sense, guys? So what we are learning is what? MySQL. So now, I would also want to give us like a brief overview of what non-relational database is. So, and for example, the MongoDB, right? So we also have another example, Cassandra. So now, the nature of non-SQL, as the name implies, right? So it means it's like it's an unstructured database or semi-structured database. So it's less concerned about having a strict policy of how a database schema is designed, right? So instead of storing database in tables like its counterparts, so they store their own data in more adaptable structures like, so we have the likes of documents or key value pairs or graph, right? So for instance, the MongoDB, right? So instead of separating users, orders, and products into multiple tables, so it can just like have somewhat a key value pair and have everything stored like like self-contained, like having everything committed into the same what the same storage. So that is what makes it different from what relational. So unlike relational, so if for instance relational wants to build like a structure, right? So a structure to like architecture, right? To have one table to store users profile, right? So in that case, let's say we are working with an e-commerce storage system. So it could build one table for just a customer's what profile, and it would also define another table where it would store like the objects, items, and the likes. So now it will now build that connection. The process of building the connection, making both tables. We have one table which stores user's profile. We also have another table that stores goods, right? Or orders, right? So how do we know that user A had checked out or added objects A into his cart? They are separated. We have one table storing items. We have another table storing profiles, right, for customers, right? So they are different, they are separated initially. So now having them to communicate, to network is what makes it relational, right? And the technology that will be doing this for us or that we will be learning is what MySQL, right? So it is not similar to non-relational. So that can just map both profile and um, items together inside the same container, right? So, and this is essentially one of the benefits of use case for this non-relational database is when you are building some databases um, that requires scalability, right? So if you want to build like a scalable database, right? So because relational is very strict, so it's many a time governed, so it's really not scalable to a great extent compared to non-relational. But if you want to build something scalable, something very fast, something more efficient, but if it is needless of data integrity, which is very important, if it's needless of data integrity, or if it's minimal to a very like minimal extent, so you might want to consider non-relational. So those are just like the primary or the differences that are like important or that should interest us. So why talking about the types of databases? So now we'll be concentrating on relational database, right? So specifically MySQL. All right, so as illustrated earlier, so it's just like a structured query language, SQL. So as the name implies, so SQL, it can also be pronounced as what? SQL, right? So, and it's a structured query language. So when we say something query, so query is like, okay, fine, I want you to go and do this for me, right? So go and do this for me, right? So it's a language that queries data, right? So queries data and gives us output as what as requested. There's always programming language, right? So designed for managing and manipulating relational databases. So when we say manipulate just basically to create, to delete, to update, and a host of others. So for interacting with SQL databases, so you have the likes of MySQL, PostgreSQL, Oracle. We also have Microsoft SQL Server, right? So SQL provides a standardized way to perform various operations on databases, so which had been mentioned before now. All right, so when we say a database management system with under the scope of MySQL, which is relational, right? So in the course of my introduction. So I mentioned something. I said for a relational database, we there are expectations, right? So we have some qualities, right? We would want it to be able to perform. So these qualities are basically two. So the first one is what? ACID, an acronym, ACID. And the other one is what? CRUD, CRUD. The former ensures or enforces data integrity, while the latter, it's concerned on data manipulation. Again, ACID's concern is primarily on what? Data integrity, right? So while the CRUD, its counterparts, right? Its own mainstream is on what? Data manipulation. So what data integrity is, what data manipulation is, would make sense in one of the what few next slides. So these concepts are so central to application design that is often used as a baseline for evaluating the completeness of programming framework. So what this means is, um, if you develop an application, right, and it is short of one amongst the qualities of both ACID and CRUD, right? So which is specific to relational database. So that application or that program could be considered like baseless, right? Could be considered baseless. So if a system cannot perform this operation on its data, they generally considered incomplete for general purpose and what data management. So because tell me how you build a database system for a banking architecture, right? That is um that is incompetent to what? To ensure a safe and uncompromised um, money movement from one end to another, right? So you are building a system that we are not confident of, right? To bestow our data with, or to bestow, to query, or to manipulate data. So essentially, it's just like a toothless what? Bulldog. So irrespective of the sophistication of the program you've built. So that is what makes this component very central and pivotal towards a database system. So what they are would be what's seen in our next slide. So we'll be starting with ACID, right? So ACID is just basically an acronym that stands for atomicity, consistency, isolation, and durability. Again, we have atomicity, consistency, isolation, and durability. So these focus properties works together to ensure. So in this case, I have cited a banking architecture as a case study, right? So um, let's say we are building a database architecture for a banking system. So expectedly, these four properties should work together to ensure that a transaction or a sequence of database operation treated as a single logical unit of work, right? So it leaves database in a valid state, even in the event of error, power failures, or other mishap. So this is just like a sum up of these four concepts that makes up ACID, right? So now let's check them one after the other. So when we say atomicity, so what do we mean? Atomicity is just like it's actually all or nothing. Again, while we are performing that operation or while we are invoking that query, this query should either succeed or failed. There is no in between. If it does not succeed, it should fail. If it does not fail, it should what? Succeed, right? So this would guarantee that all operation within transactions are treated as what? As single and indivisible units. So for example, we say that we want to let's say we are transferring money from one account to the other, right? So if the if 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 it's if the debit succeeds, right, but the credit fails, so due to one thing or the other, so the atomicity ensures that debit operation is what is reversed. Does it make sense? If we want to perform a transaction, right? So I want to transfer money from point A to point B. Um, Expectedly, a database should be able to have capability and being robust to ensure that it's either my transaction succeed completely or failed completely. So let me bring it home. Um, if we are using POS, right? So why using POS? When a transaction fails, the output you get is what? Transaction failed, right? And when it succeeds, you can also verify in your what? In the printout that this transaction was succeeded. So, but we shouldn't have a case where we would now be unsure, was it succeeded? Did it fail? No. So even if we want to have this suspicion, right? So the atomicity of a database ensures that the failure is being what? Is being reversed completely, right? And gives credence to what? To it being succeeded. So that we don't have a system whereby we won't be able to track where that specific money ended or where it disappeared in the thin air, right? So that is what atomicity stands for. So while we are trying to understand relational database. So now also consistency. So consistency is just like maintaining a valid state. So what this means is if we want to have a data integrity, right? So while we are declaring our table, so we can have some constraints. Constraints in the sense that um, we can say that, okay, fine, a user's name should only be a character. Anything different from character shouldn't be accepted while interacting with that application or with that software or with that program. While defining, what we defined was the rule, the governing rule or the governance holding the declaration or the definition of what? Of the query was while user is imputing his first name, it should be character, should be string. But in this case, we don't use string. So we are going to also check that in a second. So it should be what? It should be character. Anything outside character, so which is alphabets, would be what? Rejected completely. And this will be consistent. It is not that when a user wants to enter a username that will be stored in a database today, it accepts character. And when another user comes tomorrow, it accepts a number. That is inconsistency in play, right? But this ensures data consistency, irrespective of the time it is being what invoked, right? So that's why I illustrated here that a valid state means that data must adhere to all integrity constraints defined in the database schema. So I've explained what schema is and constraints. So I'll just do a quick recap for those that are just joining. So schema is just basically a template, right? So how you are trying to structure the table you are defining, the table you want to store your data. So you're trying to define it. Okay, fine. You say that, okay, fine. While I'm defining it, so I said that the email field, right? The email field should only accept character. The phone number field should only accept number as record, right? And also, I could also now add that all the character, it can accept character up to 50 words characters. So you can also specify that, like putting 50, putting 70, putting 30 in a bracket. So these are what's like, they are like governance, governing that table in the course of its what declaration. And this is what schema mean. You are also adding some constraints that it should not take anything more than what these 50 characters I am specifying. This is why you see um, this while trying to interact with some programs. So you just be out of what characters. So like having a character limit while trying to add update a post or while trying to add some information in the database. So this is what is being defined while declaring or while building the architecture. So that is schema. So that is the template you defined, right? So now when this is in place, irrespective of um, the season that it is being interacted with, it should always comply with these words, with these constraints. And this is what consistency mean amongst the values of what makes up a data integrity of data base. Now to the next, which is what isolation, right? So isolation also simply mean, or to simply put, mean that in a case where we want to have an occurrence of a concurrent transaction. So let's say, for instance, you have you have 2,000 naira, right, in your account. So now this 2,000 naira, at the same time you are trying to withdraw the 2,000 naira. There is also a system, a default system which you which you have subscribed to, that is also trying to what, to auto remove or to auto debit you for a what, for a subscription. Let's say you subscribe for something, a service, right? Maybe a YouTube subscription or any subscription. So now at 7 o'clock p.m. you're trying to remove your last 2,000 naira, and that is when the next subscription for your YouTube service also wants to what, remove that 2,000 naira. So in this case, what should happen? Should a database allows both subscription to succeed? Nope. So this is what isolation means. Isolation would now ensure that concurrent executing transactions do not interfere with one another. So from any single transaction's perspective, it should appear that only one operating on the database at that moment. So, and this is where the locking mechanism is being introduced in database. So what locking mechanism does is, at that time that you are trying to remove the 2,000, and another system is also trying to debit 2,000, right? So it locks one for the other and allows one to succeed. So when one succeeds, and after the completion of one, probably you are able to remove the 2,000 naira, then the other transaction gets insufficient fund feedback. So it locks it at that moment, ensuring that, because it's just like it's just violating data integrity. You have 2,000, and at that moment you are trying to run or perform a 4,000 transaction, right? So like it's like compromising the accounts, right? So which shouldn't be what it shouldn't be allowed. So this is an expectation from us as developers to be able to build a robust system that should be able to undo this, right? So, and this is what the isolation in ArcSeed does for us. So why what structuring our database? So this is the same example as what I have cited earlier. So now the last one, which sum it up, is durability, right? So durability is also not far-fetched, so it's very basic to understand. So it just guarantees that once transaction has been successfully completed, so and committed, it changes permanently stored, right? So when you purchase something, right? So and it succeeds, right? So it's succeeded, right? So it's confirmed. What is confirmed being succeeded, it is recorded and committed to being succeeded. Even if in a second after you get your confirmation and a system crashes, right? So it still validates the former state of it being what succeeded. So that is what durability what espouses. So relating to what databases, specifically relational databases. So all these are considered to be overwhelming for non-relational databases. So this is why if you are building a system that you feel you don't really need all these requirements, so you would want to consider non-relational in this regard, right? So because all this would make scale to make scale very difficult to achieve, right? So while building a robust system that comprises of all these attributes. So this is what the ArcSeed is specifically in relation to database system, right? So it's just a feature, right? It's just a feature, just a characteristics. So what a database should be able to do, right? So now on to the next, so which is CRUD. So CRUD essentially an acronym, right? So that stands for create, to read, to update, and to delete. Again, to create, to read, to update, and to delete. It is of no use of a database that doesn't permit creation of new objects or new record into its what container. So we should be able to create, should be able to read, should be able to update, should be able to what delete information. So as the case may be. Now let's put all of this into perspective, right? So now to create operation, so we want to, this is when we want to insert new records or entries into a database, right? So it's typically the first step in populating a data store. So an example is when you want to like create a new account, right, on a website or on a social application or on a banking application and a host of others, right? So the instance you click on sign up and imputes the entries, first name, last name, middle name, email, and a host of others, right? So what you are doing basically is what you are creating and committing records into a prior defined what a prior deployed database. So it is now the schema that has been defined that would now make the storage possible, right? So it is the schema that would also be a determinant to know if your entry meets the schema's constraints, the schema or the constraints requirements or otherwise, right? So now a corresponding SQL command for this is insert, right? So while you start querying or start deploying SQL, right? So to do this, right? To do this, which end users interact with. So we use the word insert. So that's just the keyword insert for what? To create a table. So this is what you use to create the table. We are going to see the syntax in one of the next slides. So that is that on what creates. So another thing we should also inspect as a functionality of a database, right? Particularly relational database. Relational database is what read. So read allows us to retrieve existing data, right? So scrolling on your social media or social application feeds, right? So trying to click on your profile page and viewing your data, your record on the page, right? So what you are doing at that instance is what? Invoking the read syntax, right? So it is this read syntax that will be what? Queried and what? Um, retrieve that data and display it for you on the screen, right? So this is more frequently used operation in most applications, right? So an example is, so when you log into your email, so application reads, just click on your inbox. So you search for a specific email in your inbox, right? So while scrolling through, what you are doing is what you are reading. Or in a case whereby you are in an e-commerce, right? So you search for a specific products on the website. So the output or the outcome of your search query displays on the screen and you can what you can see. Now a corresponding SQL for this is as a developer, right? So how do you do this? So we use the word or the keyword, right? The command select, right? So select. So this is what you query. This is what you syntax, right? To build a system that allows what reading or retrieving existing information on a software and application. So also next to create and read is what? To update, right? So expectedly, we should have an approach whereby we would need to update our existing records in a database, right? So it's essential for keeping data accurate and what's up to date. So let's say you are an employee in an organization, right? So you have your phone number. Um, earlier, probably you were initially using a specific number, right? So if you change that number, it's expected of you to make available or provide your new number, right? For the what? For the for the to be kept in your what? In your database. The process of doing this is what? Updating an existing data, right? So maybe you change your address and you just open your let's say on your LinkedIn profile, right? So your previous information on your let me use, okay, let's say your former workplace, right? Former workplace. Okay, let's say former workplace. Your form in your workplace, your former job role is maybe a junior software engineer, right? So you are now promoted and you are now a senior software engineer, right? So in that case, you can go to your LinkedIn, go to your profile and update that existing record. You change it from junior to what? To senior. So what you are doing in that sense is interacting with what? With the update query. So which you expect, because initially all these things, they are stored somewhere. They are stored somewhere. So to now go there, look for the existing one, now replace it with the new one you are updating to. So and the corresponding command for this is what? Also what? Updates. So it will change values in one or more columns of existing rows, right? So and the last one is what? Delete. Delete, delete, delete. So we also have delete operations. So we would have records that are of no use in one time or the other. And in order to free our storage, right? So we need to delete them, right? So if you are familiar with working with some users information, such as, let's say for instance now, so you are working as an IT admin. So as IT admin, you would be responsible for creating accounts for new employees, right? So in a case where an employee resigns, so it's expected to either disable or delete that employee's account with the company or with the organization, right? So for one or more reasons, one, in order to revoke access into the organization's resources, right? And on the other hand, it also serves as an approach towards to free your data or storage. So canceling online order might also trigger a delete operation on order record. So you go to an e-commerce website, so you add something to a cart, you go back to your cart and remove it from a cart. So it can also invoke or triggers a deletion query in that database. So that is that on that. So essentially, having gone through all of this, so it should begin to resonate with us why all these are very vital while talking about or while discussing database, because without a database being able to do all of this, so it is close to it being incomplete or useless. Now that we understand the concepts, the logic, and the rationale of databases, right? So we now know what the expectation is from us as developers while building a database system, right? So how do we now understand its components or its practice, right? Its practice. So I've been using some terms, right? I've been mentioning table. I have also mentioned rows. I have also cited columns, right? So what are these concepts? How are they related to database, right? So again, they are just basic words, right? They're just basic words. They're just like they're just like a naming convention. So let me put it in that way. They're just naming convention. Just like you designing a prototype. So I want to say, okay, fine, this part, I want to name this part. Um, I am labeling this part label A. I want to label this part label B. So to a very large extent, the label has little to no contribution to the prototype you've built already. But you never have to just to identify specific parts. So you can relate to it and pronounce it as what? Okay, that is label A. That is label B to differentiate what concepts. So that is what they are basically. They are not more than that. Now we'll begin with table. So table is just a fundamental component of a relational database. So which stores data in a structured format. That is its use case. When we are saying relational, the keyword is it's it stores data in a structured manner. And the system that allows us to store this in a structured manner is using a table. No more, no less. Using a table. So we are going to see a visual representation of this in a second, and it should make more sense. Now, having understanding what a table is, right? So there is another word that you would use quite often while working with MySQL or anything database is columns. Columns. So what are columns? So columns are just basically they are fields, right? So they are fields that define attributes or characteristics of an entity. So represented by a table. What does these big words or buzzwords translate? In other words, it is just naming. It's just like, okay, let me compare it to variable in Python, right? So if you are creating an object, so you can have variable to store a specific value or a record, right? So in that case, you can say first name, last name, email, phone. It's the same thing, a representation of this field. So with using the word field, it's even similar to what we are familiar with in OOP, right? And attributes, right? So we stressed this a lot while we were reviewing OOP, right? So while you are creating your table, so you have a colon. So in that colon, this is where you specify. So this is when you are creating a schema. I have used schema also countlessly in the course of this presentation. So it is where this schema in play in practice. So in that colon, so you specify that this colon should store first names. This colon should store last name. This for email and this for phone number. That is what colon is specifically, right? Now, what are rows? So rows are just known as records. So they represent individual instances. We know what instances are, right? So instance is, okay, fine. We have a colon for first name. I creating an instance of my own profile. So once I just enter Ibrahim under my first name, it should be stored in a row, right? So that row where it is stored, it's just like if we are all familiar with a spreadsheet, right? A spreadsheet. In a spreadsheet, so let's say you want to take an information. I'm looking for a very basic example I can use. Okay, so let's say, for example, so I want to take a record of every attendee of this session, right? So I can just I can either use Google Doc or I open my Excel. So in that spreadsheet, for me to be able to identify or tell apart what a first name is different from a last name, the first thing I would do is naming the columns as first name, last name, middle name, phone, blah, blah, blah. Now, I will now come under first name. I would say the first name, Victor, last name, Clement, right? Email, victor at so.com, right? So I will do the same for every attendees of this session. The rows, the other columns where I am keeping entries of the exact value of the exact record are known as rows in a table. They are known as what? Rows in a table, right? So another example is you are trying to sign up for a program or anything. So you would have some fields to fill, right? So it could be that enter your first name. So in that box, you input your first name. That your first name would now enter inside one row in the database that had been what? Deployed for that specific program you are interacting with, right? So that is what column is specifically. So while discussing database. So another thing is also relationships. So this relationship, it is until you understand its hack. So once you are able to crack its code, so you also begin to see it as the same with the likes of what table is, what rows is, and what column is, and which is the case. It is no different from other words, criteria or other components, other concepts that we are currently discussing. So when we say relationships, relationship is this should also make anything called relational database make sense. Relational database is just like creating relationship between two or more tables. Creating relationships between two or more tables. So in this case, you have table A to store specific record, table B to also store specific record, table C to also store specific record. And why are we creating these tables? We are not just creating them for creating sake. There is something we are trying to achieve. We are driving at something specifically. And this is why we are creating these tables, right? So now it could be that what we are driving at is we have a system in a school. Let's use a school management system now. So in this school management system, um, I want to have a record of students. So in this student record, right? So I should be able to invoke or query each student's data, each student record, anytime I need to use this record. So let's say, for example, I want to register for a course. So I would have a table as a developer. You'd have a table to take while working with relational database, right? DBMS. You have a table to take student's profile, a student's name, first class, matric number, um, departments, and the likes, right? So in this case, in each table, we need to have one unique identifier that can make us to tell one student apart from another student. We cannot rely on name because we can have scores of students with the same name as Ibrahim. We can have scores of students with the same name as Robert, right? So that would make it inefficient for us to want to rely on name as what? As a method to retrieve a specific information for that student. So in this case, we can rely on what? Matric number. Matric number is unique. Each student has its his or her own matric number, right? So now in that case, anytime we want to affiliate or get more information or query that student for a specific record. It could be, okay, you want to know the courses he has registered for. You want to know his course for this is level 1 courses, right? So we can use the um the matric number as a unique identity or unique identifier to query that student information. So that is that's matric number, right, is what is known as primary key. Again, the matric number, which is unique to each student, is what is known as what? Primary key. So in a table now, you would have colon. So in that colon, you can say matric number. Maybe in colon A, matric number, colon B, first name, colon C, last name, and a host of others, as the case may be. So for that colon A, right, while defining your schema, you need to now specify colon A as your primary key. Because when you need to connect the student table with another table, maybe you are storing the scores in another table. When you want to now connect students with their scores in another table, for you to be able to build this connection, you need to reference the unique identity, which is matric number, in the score table. Now, while the matric number or matric ID is being referenced in the score table, in that case, it has a change of name. Still the same thing, but a change of name. It is now in a foreign territory. So in that case, it is now being recognized as a foreign key and no more a primary key. No more, no less. That is what those concepts mean. We have two tables, right? How to build connection. I'm building an e-commerce um, application, a database for an e-commerce application. So I would have one table to record, to have a record of all items that specific e-commerce sells, right? So because you can't just map all data together. You can't map all records together. If you do that, you are practicing non-relational. So you can use approach like key value pair. You can use approach like form. You can use approach like graph and the likes. That is non-relational. So you can use the likes of Cassandra or MongoDB. But our own interest is on what? Relational. So you are working with MySQL. So in MySQL now, everything has to be what? Unique. This is for profile. This is for items. This is for prices and the likes, right? So now, when a user, you now have something like, in this case now, since it makes sense to use something like customer ID as a primary key. In this case, you can use something like a customer ID as a what? As a primary key in this case. So now, each customer has his own ID. So that is why, that is when and only when we can know that scores of claimants we have as customers are different persons. They are different individuals, right? So the first claimant would have as unique customer ID, you can say 1. The other claimant could be 2. The other one could be 3. So we also have another customer. So Victor, 4. We also have another one, Robert, 5. Have another one, Ada, 6. The list is endless, right? So now, when Ada now add something to a purchase, right? So now don't forget, purchase history is on another record, right? So you now, as a database engineer building this architecture, it is you now reference that customer ID in the product table. Don't forget, in the profile table or in the customer table, the table A, which is the customer table, the customer ID, which is unique, you need to specify it as a primary key while defining your schema, right? So in that case, it is primary key. But when you now reference it in a product table, in order to connect what Ada is purchasing, so that you won't check out Ada's purchase for Clement. So you build that connection, you network them together, you marry them together. So that practice, in that case, it now makes the customer ID becoming a foreign key. So that is what foreign key and what primary key mean. Like basically in what database system. So, and they are used to build relationships between what, amongst or between tables. So I want to believe I am able to explain this succinctly to a great extent. So let me check what we have in the chat before. Okay. Good evening, Clement. Okay, so, oh, sorry, Victor. Now, on to the next slide. So yeah, this is just a representation of everything I have been trying to illustrate, right? So now, in this case, so let's call this a customer table, right? So you can call this a customer table. So in this case, can you see everything we are saying here? The structure itself is the table. So this is where records are stored, the data are stored. It's like a container, but it's structured. Don't forget, you are dealing with what? Relational, structured. Name must be under name field. Email must be under email field. Everything is structured. And if we define in our schema that under name, it should not be empty. Don't forget the axis of consistency, right? Why we are saying that name should not be null, not null. You define not null as a constraint while you are defining your schema. Every time a user is interacting with this and wants to skip the name entry, it should receive an error, right? It should what? Receives an error. So now in this case, this is a table, right? So in this table, the first segment of this table, where we have customer ID, name, and email, it's what a column is in database. And this is field or attributes, right? It is the same in OOP. While the data entry, the records are the what? They are the rows. In this case, 1001, 1002, Mary, Jane, Jane at hotmail.com, John at gmail.com. All these are what? Records. And they are also referred to as rows. right? So I believe this makes a lot of sense. So another example is this. So let's say we also have a customer table again. So in this case, so now we use this to also explain what primary key is. But before I proceed, so that I can believe we are all syncing, so I want someone to unmute and tell me what we can use as a primary key in this table. I want someone to unmute and tell me, please. What can we use as a primary key in this table? In this case, this is the only reason I can believe we are all syncing. This table I have on the screen. So what can we consider? What can we use while defining our schema to be the primary key? Can anyone try?
Customer ID.
Thank you, Robert. Customer ID. Because in this table now, this is the only thing that is unique to each record. Anywhere we want to query John, right? We don't need to say John. We don't need to say last name. We don't need to use his phone number. But once we reference customer ID in the other table to build our relationship, so while the customer ID leaves this table and lands or meets itself in the other table, it becomes a foreign key, right? So now let's check the next slide. So now in this next slide, this would also makes what a relational table is makes more sense and clicks, right? So now in this case, we have two tables. The first table is student table, and the second table is what? Enrollment table. So in student table, you have student ID. So student ID, we have 101, 102, we have names, right? So we also have, don't forget, each table is expected to have its own primary key, right? Now, for the enrollment table, we also have enroll ID 1 and 2. We now have student ID 101, 102. We also have course such as database systems and Python programming. Now, don't forget, student ID is primary to student table. Now that we are referencing it inside the enrollment table, it is no more primary key here. It is now what? A foreign key. Now, how do we now use it as database engineer? So in this case, let's now say we in this enrollment table now, SQL, MySQL does not send whose this user is anymore. All it needs is what? The foreign key, which we have what? Made provision for. Anytime MySQL now wants to query a database to give us an information or record history for a student that is offering database system as a course, right? In this case, it now looks up to a foreign key. Once it cited that foreign key, it then connects the student ID. So now look at database systems, right? The student ID is 101, right? So it looks up and connects it to, sorry. One second. So it looks up and connects it to its what? To its relative table. So, and that is when it's now understand that, okay, fine. So when we now run the query and say that, okay, give us the information of the students offering database course. So it cites that unique identifier which is existing as a foreign key in its database and link it back to the student table. Then print out Aisha Bello for us. That is when you can now see, okay, fine, Aisha Bello is what has registered for database system. So by the time we want to start the program, we'll know where to what ration or partition her to. So she would be joining the database systems cohorts. Okay, fine. 102. Okay, fine. Let's look up. 102 is connected to John Mark. So John Mark should be joining the Python programming cohort or class. So this is how MySQL performs its operation in the backend. So all this connection has their what commands, right? So which we'll be delving into in our next session. So now the next agenda or the next thing we should be also be checking is what the SQL data types, right? So I want to believe we all understand what data types are. So what we are familiar with, so we are familiar with the likes of integer, string, boolean, floats, and the likes, right? But SQL database data types is slightly different, right? So it also support various data types. So it stores kind of data so that we can differentiate characters from numbers, numbers from time and dates, and the likes. So in this case, anything numeric type, right? So used to store numbers. So examples, they are what? You can call them integer, you can call them small ints, you can call them big ints, you can call them decimal, numeric, and floats. So if it is character, so all this, you'll be needing all this while you are what? Defining your schema. Don't forget, schema is when you are creating templates for your table. So that is when you specify. So this is where constraints are defined, right? This is where you define your constraints. So this is where you can say that, okay, fine, while you are creating this table, so I want the name, the first name entry to be character. So when you just specify CHAR, it accepts nothing but what? Character. So we are going to see an example of that in a second. So another data type is date and time. So in this case, or in this manner, you can represent them with date, time, time, date, timestamps, and the likes. Time, time, date, timestamp. So these are the options. And we also have Boolean type, right? So Boolean, which are true or false. So in Python, we know them to be either true or false, right? So with the first letter being uppercase, so the true being upper and the F being upper. But in SQL, so it is what Boolean, right? So which is a generic name for Python, which is granular here. So it is called Boolean. So that is that for data type. I hope this is clear. So now these are now basic SQL operation, right? These are basic SQL what operation. So as I have said before, at the onset of this session, I said something that all you need to understand while trying to learn um, database or DBMS, be it relational or non-relational, be it SQL or no SQL. The only thing you should bother yourself with is understanding the fundamentals. Once you get the fundamental, everything you need to do is just to go and find commands. Like, okay, fine, what is the command to create? What is the command to insert? What's the command to select? Right? That's the next thing, which you don't even need to commit or to cram. So it's upon practice becomes second to nature for you. Right? So in this case, now I will use this create a table to recap what schema and constraints are. So as you can see here, so the operation is we want to create a table now. So in this case, so this is the command we can run. So let's say we want to create something like the student table. So as you can see it here. So it says student table. So we have the colon, we also have the rows, and we have some entries, right? So now let's now say this is the command we want to run to do that, right? So SQL. So they are also called SQL, right? So we can say create table, then employees, employee being like a placeholder for what? The name of that table, not a placeholder, like just giving the table name, naming the table, employee, right? So we now want to define, we now open a bracket inside our parentheses, right? So we would now start defining our um our columns, right? So we are defining our columns. So we say employee ID. if you see in front of employee ID, we say what? INT. INT, don't forget this INT here. In our data types, INT is what? Number. So which means anything we are filling as employee ID should be an integer. That is a constraint, right? That is like a principle. Don't accept any character. Should be an integer. Another thing is we are also making employee ID our primary key. Also important, equally important, right? So we've done that. We've defined a constraint there in that first line. We move to the next one. Okay, fine. First name. Our first name should be var character, right? So, and in this case, we want it to be able to contain up to 50 characters. I would explain here. We have three constraints in this line. The first constraint is it must be character. The second constraint is it can take up to 50 characters, right? The last constraint here is not null. It should not be empty. It should not be what? It should not be empty. So we are also repeating the same thing for last name, right? So, and also for email. Now, email, we have a different constraint in this email. So if you notice in the email, it can take up to 100 characters, but it must be unique. That is, when the first employee, right, is enrolled, he used ABC at company domain, while second employee is trying to enroll. When second employee also imputes ABC at company.com, he should get an error message stating or specifying that this name or this email address has been taken, as you can all relate to it while trying to create a Gmail account. Once a name has been taken or an email address has been taken, you get an error. That's error handling. And this is where you define that, right? This is where you define that constraint. Error what? Handling. So in this case, fine, someone has taken XYZ at domain.com. Another person is coming to sign up or to create a Gmail account. So you are also imputing XYZ um, at company or domain.com. So once it senses that, right? So that consistency, don't forget in the ACID, those pillars of database management system, can you see it's in play here? So it now comes here and check this ID is not unique, or it's unique to an employee, an existing employee. So it can now give you alternatives. So okay, it can suggest another one for you to use, but it must be unique. So that is that on that. So that's how to create a table, right? So once you just do this, so you created your table. So another one is how to insert data in a table, right? How to insert data in a table. So here it just like follow this syntax, right? Basically, so you can say insert into. Can you see? We also specify that employee table. So insert into employee. Now, if you see, we have employee ID, first name, last name. We reference them, which we have defined in our creation or create schema. Then we now have another what? Entry for value. So this value would now take the record that will be stored in our rows on our table. So now one would be represented for employee ID, John for first name, Doe for last name, and the likes for what? Others, right? So this is one approach. So it also accepts multiple entries. So in the case of multiple entries, so you don't have to be doing this one after the other. So you can also do this for multiple entries, right? So when you just say values, so you have your entries, right? So you go to the next page, open another parenthesis, fill in the information for the what? For the values. So that is how we can query the insert option. So insert, right? So don't forget our CRUD. So insert is to what? To insert is also related to create, right? So our CRUD. So our CRUD are in place here. The C, don't forget our CRUD: to create, to read, to update, and to delete, right? So to create, that is create essentially. So to insert is it is also creating. You are just like you are still creating, right? So while to select, select is select is relative to in our CRUD. What is select relative to? Select is still relative to read. Yeah, it's relative to what? To read, right? So we want to get an employee's record. So if we are getting for all employees, we can say select asterisk from employees. This returns records of all employees we have in that employee table. So, but if we want to be specific on the return value, maybe just name, we need only the last name, first name, email, right? So we don't, in this case, we don't need, okay, we don't need dates. So we can just say select as select first name, last name, email from employees, and it's what returns employees record. So this is relative to read in our CRUD, right? So we also have another one for to update. So update is still the same as update, right? So while you are trying to query your database, right, to update a data. So as we have cited earlier, so you want to change your job role, right? So you can also use the update update SQL, right? So to do that. So and the last one is what? Delete. You can also delete. So for the case of delete, so you also use what? Delete. Delete still what? Goes with what? Deletes. So again, creates goes with creates in our code. Insert also goes with what? Creates. While for R, which is read, it goes with select. And for U, which is updates, it still uses what? Updates. And lastly, delete still use what? Deletes. So that is that on what? Operation. So all we just need is once we understand the basics, the rationale, the logic. So once we enter this, we are good to go. What do we have in the chat? Is my screen not visible? Or do you mean updates and deletes? Do you mean updates and deletes? Yeah. So I don't have the update and delete syntax in these slides. So, but that's just it basically. I don't have them in this slide. I don't have the update and delete in this slide. I still have a few more slides to cover. Okay, I think that is it basically. Yeah. So I think that is it basically. So that is everything we need to check today. So as we have said, just like a basic introduction into um, database, right? So understanding the logic and the rationale of what a database is. So once we appreciate this foundation or the basic, so we should be good working with what? With our database system. So I would have loved us to engage this in the SQL terminal to just run some few checks, but the system I'm connected to at the moment doesn't have the SQL terminal installed on it, so I've not deployed it yet. So, but we will be delving into this extensively in our next section. So our next section will just be basically to now work practically with SQL, right? MySQL in this case, right? So this is where we can now understand that, okay, fine. All these shenanigans that we've been expressing all this while, okay, fine. How do they actually represent? You can then relate so that we can resonate, right? So we'll be doing that extensively in our next session. So that is the end for today's session, right? So if there's any question around what we have covered this evening, please, this is a good time to ask. The floor is open for questions. So while I'm waiting for a question, if there is any, so I would like to thank you all for staying till this minute. So it's actually a short session today. So since we are not really going into writing SQL what queries or syntaxes as such. So, but I believe that with these fundamentals that we've explored, so to a very great extent, we should all be comfortable with databases now, particularly relational databases. So I want to believe now that we should be comfortable with. So what we just need now is to now get syntaxes, right? So I will share with us in the charts the updates and the delete syntax also, right? So what we just need is, okay, fine, representation. So another thing you also need to understand is for working with relation tables that have relationships, right? So it is similar to how we query instances with method in our OOP. So, for example, in OOP, if you have your class, right, and you create an instance or object of that class. So if you want to network that instance with a method in the class, so you do the instance dot that method. You can still recall. It's still the same thing in querying relationships amongst tables. So what you need to do is just do that foreign key dot the table, right? The existing table name, right? Then from there, it connects it back to its what? To its parents table. It's just like inheritance in OOP, right? So just like inheritance in OOP, just like creating like a parent-child summer relationship, right? So I think it's safe to use that narrative to an extent just for comprehension, right? So once you want to, let's say for example in our case, why we have that student and what's the other table? Student and course, I think. So in that case, so you can just say enrollment, student and enrollment. So you can just say the student ID dot enrollment. So then we can then again affiliate the student ID to its student table again. Then it's connected. So that's how you create the relationship. Then it's what gives you the output as required. So if there's any question, please bring it forward so that we can also venture into that very quickly before we call the session a evening. Questions. So I would let me stop recording so that it doesn't unnecessarily get longer.